Neoshadowing. Dr. Sarah breaks down the latest outer species stories. Sarah, so good to see you. I'm sure you're gonna be up watching the feed coming from NASA, but the expectation for these are almost at not a level. They are. It's like something we have seen for quite some time, and it's just purely because of span of land that this collapse is covering. It's grown to a lot, possibly the most people to see the collapse in this decade because it's such a large expand and there's been lots of excitements about not only happy beautiful with excitements around how we use this as key the public just in general about the science. Yeah, that's a great point. I mean, first of all, we see that this one also. We're gonna see various phases of eclipse. Take us through what we could expect. That's right. So depends on where you are in that line of totality. You will either see partial or total solar eclipse. And if you are in the area where you can see total solar eclipse, you actually see the moon move in front of the sun across its journey in totality, which is pretty incredible. Lasts for a couple of hours. The total itself is only a couple of minutes, but the transition between the moon moving across it is quite a wonderful thing to see. When you talk about what we can learn from a scientific point of view, why does that eclipse like this help us understand? What's quite exciting with eclipse like this is because it's blocking out the majority of the sunlight, we're able to get a really great view of the edges of the sun. You might hear it called the ring of fire. What's quite interesting and quite exciting is this year in a solar maximum, meaning that we have more solar activity than most year. We have more solar free, more greener masses this section, so that's a possibility of seeing more permanence and see features we wouldn't otherwise unless it was a year like this one. And so what can we learn about the sun then if you can see more of that outer ring of fire as you said? Yeah, so there's few different things some solar physicists are trying to understand how being in a solar maximum affects the permanences and the solar phase we are able to see, and just the structure of the outlet ring we see as well comparing to previous eclipses as there is a different thing we can learn, but just as a general public you look at either pin up camera or solar telescope, we are able to learn a few different features in the sun, then tie that back into the physics of what is actually happening within our sun. Interesting. How, I mean, these are not very common total solar eclipses, are they? So total solar eclipses happen approximately every 18 months or so. The problem is it doesn't always happen over land. The majority of our Earth is ocean, is water, meaning that we are very lucky when we get to a solar path, especially like the one that you're seeing tonight, where it is covering a vast amount of land. So that is quite rare in itself. And there was another particularly spectacular sign pattern used last week. Big seas of spiny Chinese space junk crashes to Earth. This is going to be an ongoing issue given there's so much up there now in space. It is, and this particular piece of space junk creates a remarkable brief field that were burning up over South California, and many people were confused or a little bit worried about the way we're seeing, which you be understand what we happening. It looks like meteors on the nth level, and what's quite concerning about this is that it's just one of many of these large-scale debris burn-ups that we're seeing the past couple of years, and it's one and that we recount more of as we enter the year when watching more steadily than ever before. It's your space, whether they be public or commercial. We're going to more of the calming down as so recommendation or change for how long satellites can actually see. In something we call low Earth orbit recommendation is that they should come down every 5 years, meaning that in that case or so we will likely be seeing satellite burn up at least every day, while the extraordinary they always burn up the atmosphere. It's not like they are going to crash somewhere on Earth. That's a fantastic question because the answer is quite complicated. So not always. Sometimes they might burn up completely in atmosphere. That's not a given though. Depends on the material they are made of. Here in Australia, we've been particularly, I won't say the lucky, but we have a lot of currencies, but we have the rich land, not only in our inland Australia. There was a species in New South Wales last year, I believe, but also washed up to our shore. So it's something that is not zero chance to happening. Okay, why is there a move for sun or lunar time? This is really interesting thing. So we have standing time around the world. We connect all of our clock to standing time. We have atomic clock to help us keep track of what time it is. But the other one is a little bit more complicated. So the moon's time actually takes a little bit differently than our time here on Earth because it has less of gravitational pull. So seconds are slightly faster in the moon ever so slightly. That's 0.02 seconds a year faster, but that is again a non-zero number when you're trying to do autonomous universe and having everything and computer programs and warranties on the moon. So having a stance time and which will involve having atomic clock likely service on the moon and all it we require for keeping accurate timekeeping for what we send human back to the moon and also Thomas system. Yeah, that's a little millisecond could actually make a difference in terms of accuracy. Absolutely, yes. And especially when you got say people down on the moon, you want at as bigger accuracy as you can, especially because these next mission are part of the Artemis program are likely going to be exploring further than we saw in the previous Apollo generation. Tell us, are you surprised by how well Japan's lunar landing is still going considering it's really patchy start? I feel a little bit proud honestly because it went it to the lunar dark. For context, this mission was designed to last one lunar day, which is about 2 Earth week. It wasn't designed to survive the lunar night, which is exceptionally cold, and this particularly rain. And normally, if you're trying to get a lander to survive lunar night or cold basking space, you have nuclear system on board to try and heat things up because we know if you make things cook cold on our tree, you'll like it. This system doesn't have any of that and it was not particularly designed to. It is amazing. Not only this last one, lunar night is last two, and it does have the potential to keep surprising us as weeks ago. That's fabulous. Well, you have a wonderful night if you're staying up. I think we're gonna be looking out to see sort of all the images that come. I'm sure we're gonna see them for a day. Thanks so much for joining us, Sarah. Thank you for having me. One more. Electronic don't like it. This system didn't have any of them and it was not particularly designed. It is amazing that not only the last one the lunar night is lasted too, and it does have the potential to keep surprising us as weeks ago. That's fabulous. Well, you have a wonderful night if you're staying up. I think we're all gonna be looking up to see sort of all the images that come. I'm sure we're gonna see them for days. Thanks so much for joining us, Sarah. Thank you for having me.